Can we model the behavior of an espresso machine with a Petri net? Hi, my name is Andreas Hense and I make videos in business process automation. Today I'll talk about the Barista Express and how to model its behavior with a Petri net. This video consists of 3 parts. The first part is just observing the behavior of the espresso machine, and the second part is about how to build Petri nets model, the methodology and all that I use. And the third part is comparing the Petri net model that we built in part 2 with the actual behavior of the espresso machine. So, if you are just interested in brewing good coffee, you may stop watching now. There are other videos for you. If you are just interested in the behavior, you may watch part 1 and then skip to part 3. And if you want to learn how to model with Petri nets, then you need to watch the whole video. So let's get started. I have the espresso machine here, and let's see how it works and what we want to model. So you can see that the machine has a power button on the left-hand side, and if we press that, the machine will start heating up its internal boiler. I suppose that there is this kind of boiler inside. And on the right-hand side, you can see 2 buttons with 1 or 2 cups. This is for single or double espresso, and they are not lit yet because the boiler is not yet hot, so it's still heating up. And on the right-hand side of the machine, you can see a dial, and the dial, you can put it to the left-hand side, and then it will produce steam via its steam wand, and you can turn it to the right-hand side to produce hot water out of this outlet in the front. So let's see what happens now. Now you can see that the machine is ready, so we can press the 1 or 2 espresso buttons, and as soon as we turn this dial on the left-hand side to the left, it will start making steam. And you can see that while this dial is turned to the left, the brew button for the espressos, the brew buttons are just switched off. So let's see what happens. Now you can see steam is coming out of the steam wand here. And let's see what happens if we turn it back to the neutral position again. You can see that now these brew buttons are still not lit up because the boiler has cooled down, and we have to wait until it's ready again to brew coffee. And now you can see that they are lit up again, so now theoretically we could brew some espresso. And the next thing that we want to do is we want to turn this dial to the right-hand side and see what happens now. So you can see immediately there's hot water coming out of this water outlet at the front, and water is going everywhere because we didn't put a cup underneath. And if we switch that back to the neutral position again, you can see immediately the brew buttons light up again. And now, after we have done all these things, we can try to brew an espresso. So we go for a double espresso. You can see now water is coming out in the middle where we normally put the portafilter, and the brewing button is blinking right now, showing us that it's actually brewing some coffee, and now it's ready. It stopped automatically, and we are done. Now, before we actually start to model our Petri net, let's look at the machine again and let's decide what to model, which parts to model, and from which parts to abstract from. That's an important step when you build a model, because the model is there to explain the behavior of this espresso machine from an outside point of view. So I'm not an expert in espresso machines, and I didn't take it apart because of the warranty. So we want to do that for explaining the behavior, and especially explain when these brew buttons are lit up or not. So what we will look at now are certain components. One is the on-off power button, so we will model that. We will not model all these parts for grinding and things like that. This is not important to us. And we will also not make a distinction between the brew buttons 1 or 2 espressi, so we just have one brew button here. And of course, we want to model this dial on the right-hand side, because that's important for this readiness of our brew buttons here. So basically we have three components. We have the power button, we have the boiling mechanism somewhere inside, and we have the dial on the right-hand side. And let's now look at these components one by one and model them with a Petri net. So I have WOPED open here, and we will first start by modeling the power button. And modeling a system like that with a Petri net is very simple. We take a place for the state, we call it power on, and another place we call it power off. And then we need two transitions to switch from one state to the other state. So we go here, and I will not name these transitions because I think their meaning is clear from the context. So one is going from power off to power on, and the other one is going from power on to power off. So this is this power button on and off. And of course we need to define what is the starting position for our machine, and we will say, okay, at the beginning we add a token here, and this means that the power is off at the starting condition, and then we have this power button modeled. Let's now model our dial on the right hand side. So for this we need three places. One is for the steam on the left-hand side. Another is for the neutral position, or I will call it off. And the third one is for hot water. And we need transitions to go from any of these states to any other state. And let's say at the beginning this is in the off position, so we add a token here, and we insert transitions from off to hot water. So this corresponds to turning the dial to the right hand side. One goes back, and then we have one that goes here to steam, and the other one goes back. So now we have this dial, and what is missing right now is our boiler. So the boiler also has two states. So one, let's call this boiler hot, and the other one is boiler cold. And we need transitions for heating the boiler, and the other one is for brewing our coffee. And of course, the boiler at the beginning is cold. So that's the initial state. We have three subsystems here. And now comes the interesting part. We have to connect these three systems according to the observed behavior of the espresso machine. So there's one thing, of course, if we have the boiler that is cold, I mean, it will never heat unless the machine has turned its power on. So we can do this in the following way. If we just want to check that there is a token here in power on, we can insert two arcs, one from power on to heat. This means that heat cannot fire unless there is a token here, but we have to put the token back in, let's say, more or less immediately, because otherwise we would switch off the power and we wouldn't have a token here. So if we just do the token game right now very quickly, you can see that here I can switch the power on and off, and the heat transition here is only activated when the power is on. Okay, that's that. The next thing is that when the boiler is hot, we can actually brew some coffee here, but we have observed that brewing coffee was only possible when this dial is in the neutral position, because if it's not in the neutral position, then we cannot brew coffee. So again, we have to do the same thing. We have to put one arc from this off position to brew, and we put another arc back to leave the token where it is. And this means that if we look at the token game again, let's say we have the token put on hot water, we put the power on, the heating is on, but we still cannot brew coffee because this is not in the right position, and only here we can brew the coffee, okay? So this is that. So next thing, what did we observe? We have observed that when we do hot water and we turn hot water off again, we are immediately ready to brew coffee. But if we have used the steam, then the machine has to heat up again. So what we have to do is we have to insert another transition called steam. This is actually the transition that goes down from hot to cold, because this is cooling down our boiler, and we have to connect that to our steam place here. So we have an arc here and we put an arc back. And so if we use steam, the boiler can cool down, and we have to wait until it heats up again. A last connection that we can insert is that if we switch the machine off, it will go from here to here. So that's our machine now, our machine model, 3 parts. And now we have to test if it's working. So let's play the token game. So in the initial position, I've seen that I made a mistake here. Actually, I wanted to have it the other way around. So let me correct that. Okay, let's play the token game. We can switch the machine on, or we can turn the dial to either position when at the starting condition. So let's turn the machine on now. The machine can heat the boiler, and PetriNet's abstract from time, so it's not defined in the PetriNet at what moment this will actually go to the heated position, but eventually it will go here. And now we are ready to brew coffee. We have to wait until it's hot again, and then we can brew another coffee. If we turn our steam dial on, we can produce some steam. Steam is coming out and the boiler is cold and we cannot brew coffee right now. That is correct. And we have to wait until the machine is hot again. We still cannot brew coffee because we have left the dial on the left-hand side. So it has to go back to the neutral position, to the off position, before we can brew coffee. And the same is true if we produce hot water. Hot water is coming out. We cannot brew coffee while hot water is running, so we have to turn it back to off before we can brew coffee. And then the machine will eventually be hot again. And at the end, we can turn it off. So that's our model. Yeah, let's now verify if this model does what we have observed with our machine. So first thing is we turn the power button on and now we wait for the machine to heat up. You can see that I've added some extra icons to make a distinction between buttons we press and things that just happen over time. And now we have to wait until our machine is ready and the boiler is hot. So let's see when that comes. The light is still blinking right now. Now it's ready. So boiler is hot. We are ready to brew. And we are also ready now to turn our dial on the right-hand side. So we can turn it either way. We can turn it to the right or to the left. So now we turn it to the left. And now we can see that steam is coming out of the steam wand. This is starting a little slowly at first. Now we can see steam coming out. You can see that we are not able to brew right now. The light is turned off, so the model is correct with that respect. And now we turn it back again. And now we are in this stage where the boiler is cold again and we have to wait until it heats up. So let's have a look. No, this is the case. So boiler is hot again. And now we are ready to try the other functionality to turn the dial to the right. And now hot water is coming out of the machine. And we can see that the brew button is not activated. So also this behavior is correct. And all we can do is turn the dial back to the neutral position, or of course we can switch the machine off. So now we have turned it back to neutral. And now the final step is actually to brew some espresso. So we will start the brew button right now. We press the brew button and now water is coming out in the middle where the portafilter is normally placed. And when this has happened, this has stopped now, and the machine will go back to the state where the boiler is hot. And last but not least, we can switch off the machine, and then we cannot brew anymore. And all we can do now is turn the dial on the right-hand side to the left and to the right. I hope you found this video useful. Do you see any points where we could improve the model? Are there perhaps any experts out there who know exactly how an espresso machine works on the inside? In any case, I'd be happy to see your comments and answer them. See you next time.